have an S, you have a B, you have an F, and then you have a C, and then you have a T, and then you have a D. And that's the flow. 20, going here is 15, going up is 6, going here is 14, going here is 15, going here is 20, then going up is 12, and then coming here is 10, and then 15. Have we left anything? No. Now let's say I want to find the maximum flow from S to T. Now if I use my earlier method, I will go mad looking and trying to find the paths and then taking the minimum and then looking at what the maximum T can handle, blah 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 blah. So what I now do is I use something called cut. What is a cut? Cut is a cut. You're cutting off the supply of, let's say this was a flow of water, flow of traffic, whatever. You're cutting off the supply from source to target fully. So you apply cuts in such a way that you cut off the supply, that if you cut off those edges, let's say this was water, water cannot flow from source to target. One example could be this. If I apply this cut, so that means I chop off. Do you think water going out would ever reach here? No, it'll just start leaking here, right? It'll just go off the road. So I say this is a cut. C1. What else? How more can you cut it? If I say I forget about cut 1, let's say I apply a cut here. And if C1 is not there, would this cut completely chop off the flow from source to target? Yes? Yeah? And I name it as this because I'm taking the example of the book. I say C3, cut number 3. If I make a cut like this, Mitch, probably do you think this cut will stop the flow of the water completely? If this was the flow of the water? Water cannot go in this direction, but then water can still flow from here back here, right? Well, yes. So this is not a valid cut. I will not consider this as a cut because I'm allowing the flow to reach from source to target, right? So I will not use this. My cuts need to be valid, right? Now, see, ideally, you can't do it like this. I cut. Now, try to chop off in one shot, right? No zigzags in the cut, not too many zigzags in the cuts. Okay, let's try to see what else can we do. I'm just taking this off. Where else can I apply a cut? Can I apply a cut like this? Let's say I pick here, cut this and cut this. Well, it's valid?
Yeah.
Mitch, is it valid? Stopping everything? Right? Anu, yes? What if I do a cut here? Valid? Yeah? Anything else can I do? I think I'm done. Any more?
Can't you cut from C to D, C to T, and D to C?
Come and draw. Come and draw. Here, show me what cut you're going to draw. And let's do a different color. Try this. Yeah, that's very important because you will be doing it by your Yep. Yes, you can.
That's C.
Yep. That's perfectly valid, correct? Awesome. Valid cut, right? All good? Let's call this cut as C2. Let's call this cut as C3, C4, and maybe a C5. Right? Now, let's now find the capacity of each cut. And once I have calculated that, the cut with the minimum capacity is the flow of my network, is the max flow of my network. That's the logic. Let's try to find the capacity of cut C1. Cut C1 has taken two edges which are worth 15 and 20. So I say 15 plus 20 is 35. Cut C2 is a bit interesting. It takes three edges, Danu, 20, 6 and 14. Right, Mitch? So it says 20 plus 6 plus 14. Now, whenever you are calculating the capacity of a cut, you need to look at the flow of the traffic, water, whatever that is. The arrow, basically, the flow. The flow should be, for every edge, the flow should always be going out of your cut. And it shouldn't be coming inside the cut. So we will only take those edges, we will only count those edges where the flow is going outside the cut, because we are trying to cut the outflow, right? And we will not consider anything which is not going out. So let's look at this edge first. Direction is downwards, that's my cut going outside. 20 is fine. What about this edge BF? If that's my cut, it's just going pretty much inside, right? It's not going out. I will not consider this. And what about the next one? Yep, going out. I will consider this. Mitch, does that make sense? So the capacity of cut C2 is 34. Ranu, does that make sense? Right? So just don't blindly add the edges. You need to take the direction, and that is why diagrams have a direction. Right? Then comes your C3. C3 takes FD, 20 going out, cool, makes sense. Taking FC going out, cool, makes sense. And 14 BC going out makes sense. Alright? That'll be 49. What next? C4. C4. 20 FD going out. Awesome. Hey, look what's happening here. Yeah, it's going reverse in the other direction, not going out. So I don't take this. The next one is CT, 10. I take that. Let's take C5. Going out, going out. Awesome. 10 plus 15. Yep. So which is 25. All good? So what will be the capacity? Which is the minimum capacity?
Okay.
Yeah. Right? So that will be the capacity of this particular diagram. In the example, he's just given you 4 cuts and he's just asking you to calculate the capacity. He's not asked you to calculate the maximum flow. We made this problem as, we extended this problem to say, okay, let's apply as many cuts as possible. Right? So the cut that Gabby has made is actually the maximum flow of this network. What I wanted to teach you is how you find the capacity of the cuts. Any doubts here? Yeah.
Wait, why is the diagonal 15 one valid but not the 6 that's going on?
Sorry, which one?
The diagonal 15, why is that like a valid cut but not the 6?
For C3,
Yeah, but not the 6 that's going on.
let's look at this cut. Where is the water going? Is it ever going to cross the cut? What about this one? You see? Any cut which is any edge, any direction which the edges involved, the direction of the edges should throw the traffic out of the cut. It's not throwing or it's just pushing it in, then we don't consider that value of the edge. Right? Make sense? Alright. What else? Let's do a question maybe. Yep. I will just highlight that on the board, which is example 3. We'll do the example 3 of chapter 14. Don't open your books, I'll just flash it on the screen. So after we've done question number 3, now we're doing question number 5 of the Cambridge book, which is page number 668 of the book. Go for it, please. Again, identify the